Welcome to my YouTube channel. So we'll be solving the question from latest Codeforces contest, that is from Codeforces round 986 division 2. The question is B, Alice's adventures in permuting. So let's first understand the question. So the question is saying is that Alice mixed up the words transmutation and permutation. She has an array A specified via three integers n, b, c. The array A has length and is given via ai is equal to b into I minus 1 plus c. So for example, if n equal to 3, b equal to 2, c equal to 1, then our array will be 1, 3, 5. Now Alice enjoys permutations and would like to transform A into permutation. In one operation, Alice replaces the maximum element of A with the max of A. If there are multiple maximum elements in A, Alice chooses the leftmost one to replace. Can you help Alice figure out how many operations she has to do for A to become a permutation for the first time? If it's impossible, you should report it. Now, generally the permutation starts from n from 1 to n, but in this case it is from 0 to n minus 1. Let's understand the equation with the help of some examples. Let's take this example of 100 to 1. This will give us more clarity. So let's say our n is equal to 100, our b is equals to 2, and c equals 1. Okay, so let's first construct our array. A is equal to, now ai as we have shown here is it's b into I minus 1 plus c, right? So the array here will be like its first element is c, then b plus c, then 2b plus c. It's like AP, arithmetic progression, right? So our array is like C with first element as A, and then we have increment of B, that is 3, that is 5, that is 7, up to its last element is what? It is 100 minus 199 into 2, it's 198 plus, so it's 199. So this is our A array, right? Now what we have to do is we have to construct this whole into a permutation, right? Permutation, okay? Permutation, and in such a way, and as we have operation to convert the maximum element to what? To max, right? So here what the array will be like, it will be 191, 193, 195, 197, and 199 from end. Okay, now what will happen is that, let's say, see, the max of the array is here is 0, right? So this 199 will be converted to what? This 199 will be converted to 0, right? In the first operation. Now what is our max? See, 0 is now present, okay? 0 is now present. This 199 is gone from here, right? 1 is now, so what is the next? Next is 2. So 2, so here 197, our maximum element will be converted to what? To 2. Similarly, 195 will be for what? For 193 to what? That element is not present is 6, right? So it will happen, and till how much? So it will be like, okay, so we could see here is that the elements, number of elements is fixed, right? So the our n is n, okay? So what is the last element of the max? It will be the of permutation, as we have constructed. It will be 0, 1, 2 up to n minus 1, right? So the last element that would be converted, so in this our n is 0 up to 99, right? Because n equals 100, n equals 100, right? Now, so please see here is that what is our last element here which will be converted? It will be 101, and which will be, so maybe 101 will be shifted to actually 98, maybe, right? Yes, sure. This will be 0, this will be 2, this 4, 6, and 8. So how many operation it took? It took around 50 operation. So this is what we have to return the answer. In the another way we can understand the question is that we have 0, so sorry, we have 1, we have 3, we have 5, We have what? We have 99, we have 101, we have 197, 199, right? Now, as we know, our permutation array, our final array is what? Final is 0, 1, 2 up to n minus 199, right? Now, as we know that this elements are already there, so these elements will be used, right? And this all elements are converted with this 0, this 2, and 4 here. 3 is there, 4, right? So if we know this, let's say how many elements are already there in this, in the array, in this AP, which are less than or equal to n minus 1, then what we can do, we know its size is n, we subtract with this element, let's say that's m, so our answer is n minus m, because these are the m elements which on which the operation will be performed, right? Understood? So now the question is that, main question is that, how to find this m. Sorry, m is actually this, and this is n minus m, which is our answer. Now the question is how to find this m, how to find this m elements. Okay, okay. So what we know that the last element is n minus 1. Okay, so let's get to the next page and let's see, we know 1, 3, it is our array, 97, 99, 199, and what is our final? 0, 1 to what? 99. So what if we find in AP? See, we know in AP what happens is that we have a plus d, a plus n minus 1 into d, right? If we know this, okay, so we can get that what is the position, what is this n from a and d, right? Means what I'm saying is that, as we know, we have 99, okay, our last element. So we find that see, this is 101, okay, so we find that which is the nearest integer that is less than or equal to this 99, right? Means let's say we have let's say for example we have 2, 4, 6 and 98, right? Right. And for some case, let's suppose we have this case 99. Let's this is not a real example, just for I'm saying this, that 98 and 100 and 102 and up to so on. Okay, now our end element is 99. I wanted to find all the elements that are less than or equal to this 99. What I need to find? I need to find its last element, that is the greatest element that is smaller than 99, right? Right. So that is smaller than 99, that is 98. And from this 98, I can get its position, that is its m position. And because its position is m, I get to know that there are m elements, and these are what? N minus m, which on which operation will be performed. Now the question is how to find this 98 here, 99. So we will use the technique of, so see what we have in our example, b into I minus 1 plus c, right? Now general AI is represented with this. Now this AI should be less than or equal to n minus 1, which we need to find. We need to find that AI. Okay, so b into I minus 1 plus c is less than or equal to n minus 1. Now what a brute force or general approach is that, see, we need to solve this expression, right? Less than or equal to n minus 1. We need to find a maximum value of this I, right? Of this I. So let's say we start from I equal to 0, then I equal to 1, then I equal to 2, and up to, we find that, okay, we find that 50th element, like b in the previous example, the b was 2 into what? 49. 50 minus 1 plus 1 is less than or equal to 99, as we can see. Further, I, so if we take I equal to 51, so it's 50 plus 1 is 2, so it is 101. It does not satisfy this 99. So we say our I equal to 50 satisfy our equation, right? So we can loop from I equal to 0, we start, and we can go till our equation gets satisfied. But this is linear approach, because the n can get to 118, which is very bad. So it can take the time complexity of 118. So we will use what? We know we need to solve this. We need to solve this expression of what? B into I minus 1 plus C less than or equal to n minus 1. What we can do? We can apply binary search. Means we can start from I equal to 1 up to, we can have a lower bound of which L is equal to 1. Highest elements. So how many operation can I perform? That's n. So let's put n. And as if, let's say, in the previous example, our n equal to 100, the previous example, okay, so b into 1 over 1 plus 100 by 2, if we do mid, it will be what? 50. So 50 minus 1 plus c, that is 2, sorry, it's 1, is not equal to 99. It will satisfy, right? B is 2, so this will, in the first loop only, it will satisfy. But this jumping happens because if it satisfy, okay, so I will do, okay, I have got a greatest number, that is 50, that satisfies this equation. What I will do, I will increase my low to what? 51. Mid plus 1, high equal to what? High is 100 only, so it will be what? 151 by 2, that is 75. Put 2 into 75 minus 1 plus 1, it is not less than or equal to 99. So we decrease our h to what? H to mid minus 1. So it was 75 mid. So now my h is 74. Now again 51 plus 74 by 2. That is 126. And okay, so sorry, it's 125. 125 by 2. It's 61. Right. Again you put it into 2 into 61 minus 1 plus 1. It's not less than or equal to 99. So it will work in log and time complexity. Our search space got decreased. We would not be doing linear search from 1 to 100. Right. Okay. Now, so the general binary search we will be applying. Okay. Now let's take some edge cases examples. Okay. So there are some edge cases examples. Let's say b equal to 0. Right. This is an edge case. In b equal to 0, the thing is that all elements will be same, right? All elements will be same. Okay, so there is issue with the same elements. If b not equal to 0, then the thing is that all are different. Then it's okay. Then we don't need to take care. Why? See, let's say our b equal to 0 and c equal to 0. Let's say in the example, if you would see this example, that is 3 0 0. It's 3 0 0. There are n equal to 3, and here is 3, n is 3, b is 0, and c is 0. Means our a array is what? A array is 0 0 0. Right? The issue with this is that what is our main motto? So what is the max of this array? It's 1. So leftmost will be converted to what? 1 0 0. Again, what is the maximum element? This is 1. So again, this will be converted to 2 0 0. Again, your operation perform maximum will be converted to 3 0 0 infinite, and we will not achieve permutation. So in this case, it is minus 1. Minus 1 means it's not possible. But wait a minute. What if n equal to 1? N equal to 1 will have a equal to 0. It will work. What if n equal to 2? So it will have 1 0. It is 0 0, and you perform operation on the leftmost element and you convert this to 1. So this will work. Okay, so not b, always b and c will give minus, but now further, if our n is greater than or equal to 3, then you can see here is that 0 0. Let's say you take 4 1, now 2. Let's understand with this b equal to 0 and with different c values. Okay, let's say our c and n. Okay, so c equals 6 and n equals 3. I'm trying to address the issue with this. So here the n equals 3, so we have 6 6 6. Is there an issue with that? No issue. First will be 0, second will be 1, third will be 2. 3 operations. Okay, the thing is that basic thing is that if c, and let's not take care about b equal to 0, if c is greater than or equal to n, I forgot this case, what do you think our answer will be? There are no elements to check. All elements are greater than n. and as we need all elements between 0 to n minus 1, so our answer is n in this case, right? Okay, sorry. So okay, so let's say our n is 6 and b equals and c equals 3 and our b equals 0, right? So now if you see here one thing, our a array is 3 3 3 3 3 3, right? The issue, so what our operation will be leftmost max convert to 0, then this to 1, this to 2, this to 3, it's already there, so now this is converted to 4. But the issue with this is that see here, the max is 4. Because the max is 4, this will be converted next to 5. We need 5 here, but because our largest element came here, it is not at last position, there is issue. Okay, let's take, so for what value of c and n we have to take care. If our c is greater than or equal to n minus 2, right, means if c is 0 1 2 3, let's say our n equals 4 and c equals 3, so we have all three, but this will be converted 0 1 2, it can easily be converted. Let's have n equal 5, then also because it's already 3, we have 0 1 2 3 and 4. But if further n is increased, right, n is increased, let's say our n equal to 6, it won't work. Okay, right? So if our c is greater than or equal to n minus 2, or we can say n minus 2 is less than or equal to c, or n is less than or equal to c plus 2, then we have no issue. We have no issue, right? Because there will be an element that will always be present in that, right? So let's take an example of 2 2 4 2. Issue is 0 1 2, no issue, right? So in this case, what we have observed is that now c can be increased. If c is here 3, it's better. C is 4 is also better. But what minimum c should be there? C here 1 will not work. So 0 1 then 2 then here 1, here is issue, right? So the length of this, that is n, and our c value should have the relation of gap of 2 only. This will work, but this will not work because n equal to 4 and c equal to 1. So it's not greater than or equal to n minus 2. So this was an edge case which we need to consider, and in this case, as there is always will be an element, so all other are converted. So for this case, our answer will be what? Our answer will be n minus 1, right? This is one case. Else our answer is minus 1, and we have a case of c is greater than or equal to n, for which our answer is right. Also the case of our what we do n equal to, what we have issue with that n equal to 2, and we see b equal to 0 and c equal to 0, n equal to 1, b equal to 0 and c equal to 0. As we see, that is both worked for only this to n, which is also satisfied in this equation. Our answer is n minus 1. Okay, so let's first take input as n p c, and let's take ll. I have used LLS long. I have defined LLS long, right? Let's take the input as n p and c. What is our first edge case? Our first edge case says if c is greater than or equal to n, then what is our answer? Our answer is n, right? Because we need all the elements that are less than or equal to n minus 1, right? Return. Okay, I have taken input here in test case here. Okay, now let's go to the next test case that was for b equal to 0. So the first thing in this case, we need to take care if c is greater than or equal to n minus 2. So what? N minus 1. The gap of c and n should be the c should be greater than or equal to n minus 2. Then it will be okay. Else what will be our answer -1 as we see here of the case here presented here of here is the case 111, right? Next let's go to the binary search. Okay, what will be our low value 1 from which we start our iteration of our ai equal to I sorry b into I -1 plus c. So we will start our this I from 1, right, and I equal to n, right, and then we'll binary search so equal to as an I mid is equal to low plus high minus low, right shift 2, okay, right, and let's store our answer as initial answer. Okay, right, now let's suppose our initial answer is 0. Okay, 0 means all is satisfied. 0 ans no m equal to 0 means all the elements, our m is here, okay, this was m, our yes, this was m, so m was the number of elements that were less than or equal to n minus 1 in the array. So okay, and I suppose that there are no elements in from the starting point. Okay, means my m is here initially, and let's start then to find further. I can't say okay my m is full, it's not valid to say now, right? Initially I am saying okay my m is 0. Okay, then I will increase gradually as I go, as binary search does. Okay, so now if let's take a check function which will include what, n comma p comma c comma mid. If it does, then I store that m is my mid and I increase my low equal to mid plus 1 as I need to find the largest element that is less than or equal to n minus 1, else I decrease my high equal to mid minus 1, and finally I output my answer as cout n minus m, right? Okay, now let's get to the check function that will be bool check. Here I'm using double here for n, double for b. I will say why I will explain you why I am using double here, and n b and c and mid. Okay, n b c and mid. Okay, so if our general function, checking thing is that the checking thing is that this bi is will be less than or equal to n minus 1. If my current mid satisfy this equation, then I will return 1, else false, right? This is what we will do. So if our expression, let's calculate our expression like expr equal to what, b into, instead of I will use mid minus 1 here, instead of I will use mid minus 1 plus c. If our expr is less than or equal to n minus 1, then return 1, else return 0. Okay, see, this thing will create an issue. Why? So let's pass our test case first, basic test case. Let's see if it get passed or not. So it get failed. Okay, so there is a cout 0 extra. Okay, so we have to return here. Okay, let's run now and see. See, this test case has got passed general, and this was at 100 to just check. Okay, but the issue with this expression is that my long will can't handle 1e18. The b can go 1e18, and as my n can go 1e18, my mid can go also go 1e18 by 2. So 1e18 into 1e18, 136. Sorry, 1e36. LL can't store here. So instead of this expr, I would convert this expr into a different thing. Means it is b into what, mid minus 1 plus c, right, plus c. Instead change to this plus c to minus c by b. Just check this. This would not create any issue, because if you will submit the before code, it will give a signed integer overflow. But using this thing, it will pass, because here we we here that there will be no issue of integer overflow. So take care, okay, if we are using this multiplication in 118, always take care, right? Okay, so if you have any doubts, you can ask in the comment section. Thank you.